Hello, I'm making this video on beta decay and that pesky electron. The electron of beta decay comes from the down quark somewhere. They don't know how. I have a theory on it, and I'm going to present that theory on this video. First of all, a gluon from my postulates are formed by how they were formed on the last video. We discussed that on the last video. But anyway, I'll go over it again. Imagine you got an electron string in each hand, and you could do that. And you take one electron string and shove it inside another. Imagine electron strings look like hula hoops. Just imagine that. An electron string goes inside the other where they touch only at the poles, when you can spin them. And they're two hula hoops 90 degrees set from one another, one inside the other, and 90 degrees. Then you take that one, another one at 45 degrees and put it in. Then you take another one at half of 45 degrees and put it in. Then you take another one at half 45 degrees and put it in until you have 8 hula hoops all stuck together that way. That should be a good visual on what gluons are shaped like. The waveform that produces them looks like this. And it is perfectly combined coherent light waves of gamma. And this is what it looks like coming straight at you out of the page. That's what it looks like coming straight at you, straight into your eye. This is the only way in nature that I can surmise that a gluon can be formed from my particles. And it has to be in a waveform because the strings of my theory are carried by light in light waves and are in photons. The strings themselves must be in light waves because light waves produce the electrons, which are massive particles, and they produce mass out of light. There's no other way around it. The gamma, all particles in this universe, in my theory, are constructed of these strings, and it's simple. All I have to do is construct the electrons and quarks out of these strings, and that creates all other particles, even the particles of the chemical table, the periodic table. Quarks, the 8-stringed gluon looks like this. What that is that hula hoop like structure, but what it is those strings bonded by the weak force, and it looks like this along one string. Notice all the circles that I've drawn in this. Those circles are strings. I call them bosons sometimes because when they're in light waves, they're bosons because they cause a light wheel to turn. If it carries a force, it's a boson. And light in a light wheel, if you shine it at a light wheel, will cause the light wheel to turn. Especially the sun. A laser, anything will cause the light wheel to spin. That's known physics. So it's a boson. If it carries force, it's a boson. Period. That's the definition. It's a force carrier and it's a particle. Okay. These strings are we're postulating just the fundamental particles that we're working with, and that electron has to be in the down quark during beta decay. The electron must be in the down quark, or the down quark is producing the electron somehow and converting into an up quark in beta decay. This is what an up quark really looks like. Make sure you can read it. Up quark. That says charge. That's hard to read. I'll write it bigger next time. Anyway, that's an up quark, a positron string, and a charge of 1. Negative charge of 1, an electron bonded to the positron by the weak force, and the leptons are bonded to the gluon by the weak force right there. This is a down quark. An up quark has a 4-string gluon, and this is the down quark has the up quark has a 4-string gluon, and the down quark has a 6-string gluon and 8 strings altogether, and the up quark has 6 strings altogether. When they beta decay, they lose 2 strings. Now, I don't know what initiates beta decay yet. Natural beta decay. The true initiator. But I wanted to make this video on this to get this point across, the 8-string gluon, what it looks like. And to get you to understand that gluons are the only thing that undergoes beta decay. The proton, they say, undergoes beta decay, but the down quark's 6-string gluon undergoes beta decay, ejects the electron and the positron, converts the positron into a neutrino. We will explain that later on in beta decay. And I know how it electromagnetically converts it. It stops it from spinning, and if it stops the positron from spinning, it instantly launches it to light speed by some force. I don't know yet. And I like this force because I've discovered it. What does launch the neutrino to almost light speed in the neutron after beta decay? That's launching it pretty fast from such a and if you take 2 protons and put them together without electrons and let them go and repulse, they'll repulse at 8,000 miles an hour, not near light speed. This particle is electromagnetically neutral. And I'll have to explain a lot more on that on later videos. But I wanted to familiarize you with the 8-string gluon on this video and to tell you that gluons are the only thing that undergoes beta decay. In the Big Bang and in gamma rays, 8-string gluons or larger string gluons come out. Well, the top quark has many more strings than 8 because it's more massive. The amount of strings in the gluon determines the mass of the quark. Because each string adds 0.511 MeV mass to the gluon, each string it has. All right, that's the takeaway from this, is what the gluon looks like, how it's structured, and that it is the only thing that undergoes beta decay. Thank you.